Welcome to Land Navigation for Search and Rescue. This video is part of a series designed to assist SAR volunteers in acquiring skills essential for safe, effective land navigation in a search and rescue environment. This video provides an introduction to topoView, a USGS website, and illustrates how the site can be used to reveal map symbols and visualize topography. Here are two ways to access topoView. This demo is being recorded using the PC-based URL access. I have also tried the QR code on my iPhone, and it seems to be fully functional also. This is the opening page of topoView, and the first thing we want to do is click on the View and Download button. This video focuses on using topoView to reveal map symbols and visualize topography. The topoView site presents a treasure trove of current and historical maps, which are very interesting and could be quite useful in a SAR environment. Okay, let's get started. Let's zoom in to an area of interest. In this case, I've picked an area just west of Yakima. And we'll click on the map, and the site brings up a list of all of the maps that are available on that area, in that area. But we're interested in the 1 to 24,000 scale maps, and we're interested in maps from like 1970s on. So let's look at this particular map, printed in 2000, and we'll show the map. Now we can see the standard USGS 7.5 minute series topographic map that is the foundation for most all search and rescue maps. I think you'll find this map is familiar. What I like about this map in particular is that it provides, just from the map view, what I consider to be the most information about the topography of any of the map series. We will talk more about interpreting topography later on in this video. But first, let's talk about a fun new way to explore map symbols. First thing we're going to do is hide this map, and then I want to find a new area, pan over to a more urban area so we can see some different map symbols. Now I'm going to check out this area. First thing I'm going to do is show the map like we did before, just to make sure we're in the right area. Here we are. Okay, that's the right area, so I'm going to hide that map. And then here's the new step. We're going to download this KMZ file. Going to save the KMZ file and open the KMZ file, and it opens in Google Earth. I think it's kind of interesting to see the U.S. National Grid patterns as we zoom in on the map that we're interested in. So here's our map, and this is a map which is overlaid on the Google Earth image using the KMZ file. And there's the symbol for a pretty big power line right away. So I'll just click off the map and look at there. There's the satellite image of that power line right away. Pretty quick reveal. Pretty quick way to check out what a map symbol looks like on the ground. Here's a little pond. Let's look at the pond. Zoom in a little bit. Well, there's the pond. Now, of course, there are houses around this pond which were built after the map was made. Let's look at another area. We'll go across the road over here and look at a pipeline. There's the symbol for pipeline. Zoom in a little bit. Click off the map view and see the satellite image of the pipeline. Pretty neat way to learn about the connection between map symbols and the actual on-the-ground features. One more, I think. Here's a swampy area, big swampy area. The map symbols for that. So let's click it off and see, whoop, there's the satellite image, and you can see the swampy looking area. So this is a trick. I find it kind of exciting, especially when you want to teach people how to read maps and how to look at map symbols, because this gives you an instant correlation between the map symbol and the ground feature. It's one of the ways you can use topoView. So give it a try. topoView can also be used to visualize topography by creating a 3D-like effect. So let's take a look at how that works. We can find a location in the United States by just typing in a name. Saves a little bit of scrolling around just to show you how that works. But we're going to go back over to this area that we were at earlier, the Darland Mountain. Remember, we're going to use, actually, I think from the 1960s is when they first started making the 24,000 maps. So let's see what we can find. Here's one from 1967. We're going to show the map. And I picked this one because it's like almost the very original topography, the very original topographic map. So here's the traditional topographic map. You can see the contour lines. We can zoom in a little bit. No, maybe not on this view, but you can see that there's an open area because it's white, and you can see the contour lines are very close together, so you expect it to be steep. Let's take a look at the way we can visualize topography. So we're going to download the KMZ file again like we did before. Going to save that KMZ file, and then we're going to open it in Google Earth. Done this before. If I can get it to open, there we go. Zooming in, I have clicked on the U.S. military grid system, but it's the same as, or looks the same as the U.S. national grid. We're going to go to Darland Mountain and open this map up. I'm going to zoom in. Now we can zoom in. But now let's just look at this map. It's the traditional flat looking map. You can see this area that's open, no timber, and you can tell by the contour lines that it's pretty steep. Now let's try to visualize this in a more three-dimensional way using Google Earth. What the trick is to go down here and click on terrain. I'll have to back out a little bit. But once I've clicked on terrain, this image is wrapped onto Google Earth, and if I move it slowly, I think you'll be able to see the three-dimensional effect pop up. Most people will be able to see this. It may take a little bit of practice on your part to get your eyes adjusted to that. But as I move this around, I believe you can see that the image reveals a kind of a three-dimensional tone to it. And here we are at our area that we started off looking at. Let's zoom in just a little bit more. See, it's sort of at the bottom of a ridge line, and there's a little road right through there, but it's really steep here. So here's the reveal with Google Earth and topoView. Look at that. Oh my goodness. There's this barren hillside that goes really steep down into that road. Look at that. So this is what the topographic map looks like. Look at the three-dimensional image. If I take off the terrain, we'll go back to the flat map. There you've got the flat map. Okay, how about that? We'll try another view in the next portion of this video. Here's another look at the process of revealing topography in 3D with topoView. I've already moved down to an area in near the Steens Mountains in Oregon and selected a map. So we're going to go ahead with the download of the KMZ file, save the file, open it up in Google Earth. All right. One thing I haven't talked about in the process so far is, you can use the functionality of Google Earth to pan and zoom and tilt your view so that you can see, more readily see the topography. But I like this glaciated canyon right here because it really shows up nicely. So especially if I turn it, and I'm going to turn it back, if I turn it this way, so we're sort of looking up the valley, and you can see if I zoom in here, this ridge line and the dramatic glaciated valley. So let's turn on the 3D view. And sometimes when you turn on the 3D view, you really have to back out a little bit to get it to pop up for you. But here we go. Certainly you can see the ridge line as I pan around. You see how the steepness of the valley. Now, I have set this up so that the vertical element is exaggerated so that we can more readily see this sort of hypothetical 3D image. I think if you watch this area here as I move around, boy, you can just see that's looking pretty steep, isn't it? It looks a lot steeper than it is because of the exaggeration I've turned on, but that's just part of the process. Let's look at this area right here. That just looks like a bunch of cliffs, doesn't it? So I'll just turn this off and look right there, boy. You can just see that cliff face right there. Back on, zoom around a little bit, seeing the here again we have a really steep area. You'd expect that to be cliffs, and sure enough, it really is. So I just think this is most interesting way to look at topographic maps. You know, talk about saddles and ridge lines. You know, all those features, glaciated valleys. Um, this all shows up just so interestingly in this particular way to view the map. Here again, you're going to have some cliffs, I'm sure. There they are. Wow. So that's how it works. There are tools to use in Google Earth to, like I said, to um, move the view around and exaggerate the topography, to tilt. If you haven't used Google, to tilt the view and see the topography in 3D. Look at that. My, oh my. So I'm going to click that off again. So there you go. There's Google Earth, and you can certainly see the kind of the three-dimensional parts of that. And then when I click the map on, you see how the map just drapes itself over that topography. Really interesting. But it certainly helps you read or learn to read the topographic map and see how the contour lines can be used to visualize the topography. Okay, here's one last view and one last comment about the topographic maps and the topographic view. We've been working with this map from the 1968 version, the earlier versions, and we looked at how well it showed up the cliffs. So let me see if I can turn that off. You see that cliff just pops right out. Show that again. Unfortunately, for me anyway, the newer versions of the topographic maps have sort of uh, averaged out the topography to where you don't really get to see that cliff. That looks steep and it looks cliffy, but it doesn't have the visual pop that we saw earlier. See these cliffs? You know they're cliffs, but they're not visually as dramatic. Now remember there was a little cliff in here before. Let's see if I can bring that out again. There's the cliff. No, which map have I got here? I don't know. There's the cliff. 2014 map. See if I can get that to show up again. Yeah, okay. So there's the cliff. There's the 2014. There's the cliff. There's 2014. Yeah, you know, if you were careful, you'd know there was a cliff there. But what I like is this map right here. There's no question when you look at that map that that's cliffy. The same as this right here. See that? I mean, visually it just pops right in your face. Oh, these are cliffs. But unfortunately, with the newer versions of the map, it's not so dramatic. It's not so visually informative, and I'm disappointed with that. But you know, with the newer maps, you always have. Oh, well, you don't always have the satellite image on the background. I mean, you know, you may or may not have the satellite image to work off of. So, just caution when you're looking at the newer maps and looking at the contour lines in the newer maps. You really have to be, you know, careful to look at where they're spaced tightly together, and with practice you interpret that to be, you know, big cliffs, because for me it just doesn't pop out the same way as it did with the older maps. The original, these are sort of averaged out maps from the original ones. So there you go. The videos for map reading, compass work, and GPS operation are designed to address Washington State's land navigation core competency requirements for ground searchers.